Howdy and welcome back. In this video, I'd like to introduce two-dimensional vectors in the C++ language. But before we do, I'd like to go ahead and get started with just a brief review of one-dimensional vectors. Hopefully you can read my handwriting. I didn't prepare slides for this video here, but I wanted to sketch it out and hopefully this will be beneficial. Recall that we can create a new empty vector by writing a declaration of the sort standard template library vector. Let's make it of integer values. So let's say int, and let's go ahead and name our vector, I don't know, vect. Now at this point, if you recall, we said that we can kind of think about this vector as empty, and we're going to get into the actual underlying process and what's happening to a standard template library vector behind the or under the hood in a later video. But for now, let's just understand that it grows. So we could go ahead and push an element into our vector by writing, say, vect.push back. And let's say the integer value of 1, which would make vect look like this, just a single element there. If we went ahead and pushed back, say, an additional integer to vect, so vect.pushback, let's say the integer value of 2, it would be added on the top of our vector. And each time this is going to effectively increase the size of our vector by 1. You can think about the size as the number of elements residing within vect. So if we were to write vect.size at this point, we'd see the result of 2 because there's 2 elements within our vector. Likewise, if you remember, we can access the elements within our vector by writing statements such as vect.at, say the 0th index, because remember, our arrays and vectors in C++ are indexed, or the first available slot is going to be at location 0, and then the subsequent slot at index 1, and so on up until size -1. So that would evaluate to 1. Okay, cool. One thing to note here is that each time we're pushing back to our vector, we're adding things on, and there's this illusion that it's growing. However, this operation can be expensive because each time the vector reaches some capacity, a resize operation needs to take place. And we'll get into that later on in the course. You'll see exactly how that's happening, why it's happening, and probably more than you might like to know. But we'll really get into that here within a little bit later in the course. Since that can be an expensive operation, let's assume that you know kind of roughly how many elements you'd like or are going to be placed in your vector. What we can do is perform a preallocation so that our vector starts out with some size. So some number of elements already in that. To do that, we would just write a declaration of this sort, certain template library vector. We'll go with ints again, and let's just call it vect. Now we can provide 2 arguments to what you all will come to know as a standard template library vector's parameterized constructor. The first one would be the number of elements. The second one would be the default kind of value for those new elements. So we're actually going to create a vector of whatever size is going to be specified here. So if I say 4, it's going to go to a bigger number, but I realize I'd have to draw that out. What that's creating or setting vect up as is a vect of 4 elements. Now, if we don't provide anything else, if we just close that out, these elements would be initialized to the 0 value of the type. For integer, that's 0. So we could think about that as 0, 0, 0, 0. If we asked vect what its size was, it would be 4. If we wanted to access the elements within vect, the valid indexes would be 0 through size -1, so 0 through 3. Additionally, we could go ahead and provide a initializing value for each of those elements. So if I go with 2, instead of each element within vect being initialized to 0, the 0 value of the type, this time it would be 2. And this would be the starting configuration of our vector. So let's go ahead and move on into 2 dimensions here and look at how we can kind of leverage this to create a 2-dimensional vector or a vector of vectors. So let me go ahead and get this set it up and we'll move into that topic here shortly. So two-dimensional vectors. Let's go ahead and create a declaration for a vector of vectors, which will give us the effectively two dimensions. So let's say we have a standard template library vector whose elements is going to be standard template library vectors of, let's say, integer values. Let's go ahead and name this vector vect. Now, everything that you've seen in the case of the one-dimensional vector is going to be relevant here. The only difference is that our vector, our two-dimensional vector, is going to have its elements as vectors, in this case, vectors of integers. So if I want to push back to our two-dimensional vect, I'm going to need to have a vector to push back to it. So let's go ahead and say that we have another vector of integers. And let's just call it A. And let's provide it with a single integer value. Let's go ahead and create another one. We do a different color here so we can see what's happening. Hopefully this isn't too bright. Vector int, we'll call it B, and it will start out with, I don't know, 2, 3. Okay. So vect, again, is kind of starting out empty. That's the illusion that we have here. It's empty and we can add to it and it will grow for us, as we pointed out in the previous video. So I could go ahead and write vect, ensuring I have the right color, vect dot push back, and we're going to push back our vector A. In this case, a copy of A would be pushed back. So at this point, vect looks like this. Vect has a single element, and its element is going to be a vector of one element, A. Now, if we push back B, notice that B is also a vector. So vect dot push back B. And notice that B is really getting us into that two dimension, right? It's a vector of multiple elements. So we can see here, 2 and 3. If I were to write vect dot at location 0, that is going to give me back this entire vector here. That's just a vector of one element. If I write vect dot at 1, that's going to give us the vector residing at index 1 in vect, which is going to be another vector. That will give us this whole vector back. So if I want to interact with that vector at index 1, I have to index into the vector. And this at gives us back that whole vector. So at this point, I could write something like vect dot at 1, and that gets me everything highlighted, and I could write dot size, which is asking the vector highlighted in yellow, what is your size? Well, its size is going to be 2 because it has 2 elements. Notice that anything we can do to a vector, we can do to the vector at position 1 in our vect, or any other position for that matter, because every element within vect is a vector. So if I write something like vect dot, vect dot at 1 dot at 1, that is going to give me the element residing in the highlighted vector at location 1. And you could assign to it, so you could do something like vect dot, right color, vect dot at 1, so getting us the highlighted vector dot at, let's go with 0 this time, equals 5. This would isolate this element of our vector, and it would update its value to 5. Okay, so we can, and you can think about how you could put this in a loop, and maybe if you're reading data, a row of data from a file, create a vector, push it back to our vector of vectors. That's all, nice. However, keep in mind that as we talked about in the one-dimensional vector, some sort of resizing process has to go on to make that work, which can become computationally expensive. What we can do to get around that is go ahead and pre-allocate our two-dimensional vector. For instance, if we knew that we wanted a vector of, let's say, unsigned int height equals, I don't know, let's keep it easy to draw, 4. So 4 vectors, each with, say, a width of, I don't know, 2. Okay, if we want to create a vector that's pre-allocated, it's exactly as we kind of did up here in this case, but now we want to do it for the two-dimensional vector. Let me go ahead and block out some of this so we can see where part of it starts, where the other ends. All we're going to do is write a declaration of this form. The type that we're declaring is going to be a vector of vectors of, let's go ahead and just go again with ints. So vector, int. We can name it our old friend vect. And think back to that one-dimensional case. What was the first value that we passed to this thing called a parameterized constructor? Well, that was the number of elements that we wanted. And we can think about this as the height. So go ahead and say height. We've effectively received what we're setting up here is a vector of 4 vectors. GHT. Okay. Now, to get the two-dimensionality here, the second argument is going to be critical. So let me do this in a different color here. I don't know, are you all feeling maybe something like red? So this is going to carry on to the next line. We're going to say that each of those rows, if you will, each of the vectors presenting in this two-dimensional vector is going to be initialized as a standard template library vector of integer objects. And now we can provide a size, in this case, width, which will be 2. And if we wanted to provide a default argument, we could go ahead and say, I don't know, 0. And that's our declaration of a two-dimensional vector with its size pre-allocated. So what that's going to do is we're going to take this out, into 2 dimensions. So each one is going to be a vector of 2 elements. Hopefully you all can see this. I know I'm dotting. Probably should have just drew it in black or something. But here we can see that we have, I'll go from the bottom up, I suppose. At index 0, we have a two-dimensional vector. At index 1, we have a two-dimensional vector, 2, and 3. So 4, we have a one-dimensional vector in each of those rows. So from at the element at vec.at0 is going to be a standard template library vector of two elements, and the initial value of each of those was as specified 0. Let me do that in a different color. No, 0, 0, 0, 0, 0, 0. So again, writing something like, in this case, vect at, say, 0 is going to give us back this whole vector here. And then if we say in that vector, we want the thing at location or index 1, that is now going to return to us this object here. So hopefully you can see kind of what's going on here, how this works. Also, how you can not only kind of create two-dimensional vectors by creating an object of type vector, vector int, storing elements of something you're interested in this case. And And then if you have vectors that you've created, you can go ahead and push them back into vect. Again, that can be expensive. So if you know how much data you're dealing with, go ahead and perform the pre-allocation up front. If you know you're dealing with some sort of height, so some number that you could think about it as a file, maybe like maybe each row is a vector. So in this case, vec.at0 would provide a particular row of data. If you're looking at this in maybe an Excel spreadsheet, that would be like all of the data, that whole first row. And then if we wanted to get into a particular column within that row, we then just go ahead and index into that vector. So what we're kind of doing, and I guess that we brought up Excel, you open it up, haven't done so in a while, and just kind of provide maybe an example here. I don't know if it'll help or not, but let's pop over there. So, I mean, you could think about this as a vector of a ton of I don't know, some huge number of vectors. If we write vec.at, let's say 1, even though we're 0 index, we get that whole vector there. And then if we say dot at b, you'd get into this person here. So that's identical to what I'm saying here with 0 indexing, is that if you write vec.at0, you get that whole kind of row, that whole vector occupying position 0 within vect, which is simply a vector whose elements are vectors, whose elements are ints. And then we can get actually into the vector at position 0, at index 0 within vect by indexing further. Because again, remember that blue line, that vec.at 0 is going to return a vector. So you could ask it its size. So you could do something like vect.at0.size, and it would report back 2. So how would you iterate through this? Well, you need a for statement to go through each of the rows. Let's go ahead and call them. So if you did something like for, let's go size t, and we'll call it row is equal to 0, row is less than vect.size. We'll go ahead and increment row plus row. If we just had that, each time if we wrote something like vect.at row on the 0th iteration through, if we're working with this guy over here, we'd return that one. Second iteration through, we'd have this vector. Third iteration through that one. Fourth iteration through, we'd have that one. Okay, what if we want to print out, I don't know, all of the integers residing within this data set? Well, we could go ahead and do something like, okay, well, if we have a row, we now need to visit each integer value within that row. So we need another for statement for that. For size t, column equals 0, column is less than vect.at rows size. And the reason we're doing that is because, as in this first example over here, we could have set things up such that each vector within a given row had a different size. So it might not always be in the case on the right where it was always 2, because you could set something up like that. So it's always just best to go ahead and ask, hey, what size are you? And go ahead and use that as we're going through. Okay. And let's say all we want to do in this case is std cout whatever's at vect.at row.at column. And then we'll go ahead and put a space. And then what we could also do here is, after we've gone through the contents of each row, we could go ahead and put a line feed. So that each row is separated with a line feed, so that not all of the elements are printed to the same line. So if we were to run through this, we first get back, let's say on the first iteration, using this vect over here, we get back that vector. We run through and we visit both this element. So we'd be printing out here 0, followed by 0. At that point, we visited every element within the vector residing at vec's 0th position. we'd hit this line feed, we'd go up to the next one because now we're at vectat row and row is equal to 1. So we're printing out that one, moving on to the next because we're in that inner for loop, another line feed, and this process continues until we've visited every data point within this two-dimensional vector. So hopefully this helps. I know it was kind of a quick and hopefully still legible introduction to two-dimensional vectors. Again, if you know kind of the amount of data you're working with, do prefer the preallocation here where you're actually setting up a vector. Vectors where where the size is specified up front. In that case, you would just go ahead and if you're looping through, say, data out of file, instead of pushing back or anything, you would just be accessing the individual locations within that two-dimensional vector to assign the data to. In the other case, if you were didn't know how much data you were dealing with, you could just create a empty two-dimensional vector. As you're reading maybe a row of data from a file, go ahead and populate out a vector. You could call it row. And then once you've read everything from that line, you could push back that row vector to vect and then move on to the next line. So hopefully this was productive. Hopefully you learned a bit and hopefully this is beneficial moving forward. Take care, y'all.